Hello and welcome. I am back with another videos. Myself, Mohiuddin Ahmed. I am your chemistry teacher. Today we'll see a very important concepts and which is equally important for class 11 as well as class 12 students, which is related to shape and how to draw the shape of a compound, then hybridization in easiest way. Okay, so just some of the things you have to remember first, and after that you have to utilize. Okay, so just like you have to, any compound is given just like PCl5. Okay, PCl5. So preliminary thing is that first of all you have to get, or you have to know the ideas about the electron pairs, how much or how many electron pairs related to this compound, which is called Z, and Z is called electron pair. After that you have to know, or you have to know the ideas about bone pairs. This is called, I am writing in short form, BP, bone pairs. And you should know the ideas about lone pairs also. This is LP. Okay, after that you can easily draw the structures, or you can get the ideas about hybridization easily. Okay, so before going to draw the structures, and some of the things you should remember, or you should have to memorize. Okay, so I'm giving a chart, simple chart, and you have to memorize it. Okay, let me erase this portion first. Okay, all right. So for minimum value, I am taking, and Z is equal to 3, and Z is which, what is Z? Z is an electron pair, and for Z is equal to 3, and first variation is if bone pair is BP, bone pair, if bone pair is 3 and lone pair is 0, then the shape will be trigonal, planar. Okay, then another variations in Z is equal to 3, electron pair 3, bone pair is 2 and a lone pair is 1. Then it is bent or angular shape. Angular shape. Okay. So these are the two variations in electron pair 3. Okay. After that, for electron pair 4, if bone pair is 4 and lone pair is 0, that is there is no lone pair, then the shape will be tetrahedral. Okay, if you don't know about the ideas about the shape, then how we can draw the structures. Okay, after that, if bone pair is 3 and lone pair is 1, then it is called pyramidal shape. After that, if bone pair is 2 and a lone pair is 2, then it is again called bent or angular shape. So how many variations? There is 3 variations in Z is equal to 4, and Z is electron pair. Okay, I'm going to erase this portion first. You can take a screenshot also, or you can uh, write in your copy. For Z is equal to 5, I'm quickly writing. Z is equal to 5. Bone pair, if bone pair is 5 and lone pair is 0, then it is called trigonal bipyramidal. Bipyramidal. If bone pair is 4 and lone pair is 1, then it is a structure is called seesaw. Okay. After that, if bone pair is 3 and lone pair is 2, then it is called T-shape. T-shape structure. Then their bone pair is 2 and again lone pair is 3. That is gradually lone pair is increasing. Then it is linear shape. Okay, so these are the structures you should remember. If you don't remember this structure, there is a waste. Okay, you cannot draw, or you cannot get the ideas about the shape symmetry. So this is mandatory. After that, for Z is equal to 6, variation is if bone pair is 6 and a lone pair is 0, then it is called octahedral. If bone pair is 5 and a lone pair is 1, then it is called then it is called square pyramidal. Pyramidal. Okay, if bone pair is 4 and lone pair is 2, then it is called square planar. Okay, planar. These are the variations. In z is equal to 6, 3 variations are there. You have to remember the variation. So now if for z is equal to 7 and there is two variations important, basically important in z is equal to 7. If one pair is 7 and a lone pair is 0, then it is called pentagonal bipyramidal. Pentagonal bipyramidal. If bone pair is 6 and lone pair is 1, then it is called distorted octahedral. So these are the total variations, and up to z is equal to 7. Okay, just try to memorize all the variations, and after that now one by one I will see how we can draw and comment on the hybridization. Okay, one by one I will see the compound. I have written total 8 compound, and one by one I will see. First of all, taken a compound which is PCl5. So before going to draw the structure, first of all, how we can find out the values of Z? And there is a formula. You should remember the formula, and I'm just writing the formula, which is Z is equal to, and Z is electron pair. How we can find out quickly? Half of, this is half of valence electron of Ca, means central atom, plus number of monovalent atoms. Okay, and if the compound is an ionic, it may be cationic or anionic compound, then just for positive cationic compound, just subtract -1 from this formula, or for anionic compound, valence electron of central atom plus number of monovalent atom, and then plus 1 for anionic compound. That is, add 1 for anionic compound and for subtract -1 for cationic compound. Okay, and for neutral, just leave it as it is, just valence electron of central atom plus number of monovalent atoms. Now see the what are the monovalent atom? It may be hydrogen single bonded atoms which is bonded single bonded. Fluorine, it may be chlorine, bromine, iodine. So these are monovalent atoms. So for PCl5, how you can find out the values of Z? Z is equal to half of, well, central atom is phosphorus, because phosphorus is only singly present, which is less in number, and basically the atom which is less in number we can consider as a central atom. So valence electrons for phosphorus is 5 plus number of monovalent atom is 5 again. For 5 chlorines are there, then 5, just add it. So there is neutral atom, so there is no need to add or subtract. Okay, 5 plus 15 by 2, and this is again 5. Now in these 5 there is an combination of bone pair and lone pair. Okay, so how we can find out the bone pair and lone pair? For 5, just see how much atom is bonded with phosphorus or central atom. There is 5 chlorine is attached with phosphorus, then bone pair will be 5 and lone pair is 0, because total you have to see the totals is 5. Okay, in 5 there is 5 bone pair, that is nothing lone pair. Okay, so then the structure will be like that. Make a plane trigonal planar shape, and after that and top and bottom, and this is above the plane and below the plane, above the plane and below the plane, then chlorine, chlorine and chlorine, and this is called 5 0 bone pair 5 lone pair 0, and it is called trigonal bipyramidal. Okay, I hope you understand how we can find out. So TB, trigonal bipyramidal, TBP. Okay, this is how you can draw. It is also from 90 degree. So if these two positions are suitable position which minimize the repulsion, and if you see that repulsion order, then you may find out lone pair repulsion is very dominant. After that, lone pair bone pair repulsion, and after that bone pair repulsion, which is very less in magnitude. So you have to see these are the, or you have to count these are these effect also. Okay, so in this way you can see, or you can find out the shape geometry. And one thing you may find out the hybridization is also hybridization also. Okay, how we can find out the hybridization? This is total 5. If the value of z is 5, then hybridization will be sp3b hybridization. Okay, just simply find out. If the value of z is 4, then hybridization will be sp3. If the values of z is 6, then hybridization will be sp3d2. Okay, 2, 5 and 6. Okay, like that. So just remember it. Now I'll say another structure. Find the values of Z. How you can find out the values of Z? This is Z is equal to valence electron of central atom. Xenon is noble gas, that it will be 8. And how many monovalent atom? Fluorine 2 monovalent atom. This is 10 by 2. Again it will be 5. Okay. Now see the bone pairs and lone pairs. Bone pairs. How many bone pairs? See how many atom is bonded. Fluorine 2 atom is bonded, then bond pair will be 2. And how we can find out the values of lone pair? Lone pair will be total values is z, lone pair per lone pair, then 2 is bond pair, and then rest of the 3 electron pair will be lone pair. Okay, 2 3 and 2 3, if you see the shape, that it would be linear shape. Okay, linear shape. So now how we can draw it? So just see. So xenon will be in central atom. After that, this is plane. Make a plane. Okay, trigonal planar shape. After that, one above the plane and below the plane. And lone pair will be in maximum distance. Then 3 lone pair, I will make these 3 position as a lone pair, because these 3 positions are 120 degree apart, and one fluorine will be here and one fluorine will be here. This is the simply you can find out the shape, and this is called linear. You can see that this is linear structure. Okay, like straight line. Okay, this is linear structure. Linear. This is pretty simple. How you can find out the hybridization? Hybridization will be sp3d. Total 3p orbital, 1s orbital and 1d orbital. And after the all the mixing, you can see the 5 orbitals, and hybridization will be 5. So this is how you can find out. Next structure, again see the values of z. Z is equal to half of again xenon is noble gas. It will be 8 valence electron. How many monovalent atom? This is 6 monovalent atom. 8 plus 6, 14 by 2. It will be, so it will be 7. And after that, how many bond pair? Just see the rules. And what are the how many atoms attached? Bonded atoms. This is 6 bonded atom. Bond pair will be 6. Then rest of the electron pair will be lone pair. 7 minus 6, it will be 1. So 6 1 is a little bit interesting. This is called distorted octahedral. I have not mentioned. Just remember distorted octahedral. So for distorted octahedral, how we can draw? Just see. This is make an square. After that, and up and down, and some in angle. You see the lone pairs in angle. Okay, this is electron pair, one electron pair, which is lone pair, and then rest of the positions will be occupied with fluorine. Okay, this in this way. Okay, so this is called distorted octahedral, and the lone pair you have to make in some angles. Okay, and above, and this is above and below the planes, and these 4 angles are in a plane. Okay, so in this way you can find out. And what will be the hybridization? This is sp3 I think great students. We'll see another compound which is XeWa4, and this is really interesting. Just find the value of Z. Z is how much? Half of what is central metal atom? This is noble gas xenon 8 plus. Now you have to correctly put the values. What is the meaning is that how much number of monovalent atom attached to central metal atom. Oxygen is not monovalent, it is divalent. Oxygen, nitrogen, these are trivalent and trivalent respectively. So fluorine is a monovalent atom, that is 4 fluorine it is attached. So just mention monovalent atom and it is neutral, close it. Okay, 8 plus 4 again 12 by 2 it is 6. Okay, now we have to see the bone pairs as well as lone pairs. What is the bone pairs? For bone pairs, see how much bonded atoms are attached with central atom. Central atom is xenon. How much bonded atom? 4 plus 1. Oxygen is also, it may be divalent, it may be trivalent, or it may be monovalent. Do not look for that. Just see how much atom. 4 plus 1, it is 5 atom, then bone pair will be 5. So we will treat as a double bond, triple bond, or polyvalent compound. Polyvalent atoms, maybe you just compare as in 1. Okay, it is 5. Okay, and a lone pair will be 6. For 6 it is 5 bone pair, then 1 will be lone pair. 5 1 5 1, what will be the shape related to 5 1? Bone pair 5, lone pair 1 is square pyramidal. So this is really interesting, just look for that. So xenon will be central atom, and here uh, oxygen will be generally bonded with double bond, and that's why I mention it. And one fluorine here, fluorine, and fluorine. Okay, basically 4 fluorine are there, then these will be your lone pair. Okay, lone pair, this will be your lone pair. I discarded one fluorine, and you will have to make one lone pair also. So this is the structure which is called square pyramidal. Okay, this is your square, and a kind of this is like pyramid. Okay, so this is called square pyramidal. And now we're gonna see the another structures which is ns4 positive. We have to look for that. Now we have to see another one. This is number 8, ns4 positive, and first time we are taking an cationic compound. Find the value of z. Half of nitrogen for valence electron is 5. How much monovalent? Hydrogen 4 monovalent, it will be plus 4. For ionic compound or cationic compound, for positive you have to subtract minus 1, and for negative anionic compound you have to plus 1. Okay, add plus 1. Okay, so it will be 9 minus 1, 8 by 2, it will be 4. Okay, how much bone pair? Bone pair will be 4. Why it is 4? Because how many bonded atoms are there? Total number of bonded atom is 4. Then bone pair will be 4 and lone pair will be 0, because total electron pair is 4 you have. Then 4 0 4 0, that means it is tetrahedral. So now what will be the structure looks like? This is the structure of tetrahedral. Okay, like that. Hydrogen, 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 and hydrogen, and this is the structure. And you can make the positive charge in this position, or you can put in the overall, you consider it as an overall charge, and you can put here also. Okay, so I just make it here, but do not make or do not put the positive charge in bond side atom. Okay, always positive charge contains central metal atom. Remember this things, or this negative charge contain the side atoms, and positive charge always contain central metal atom. Okay, so I think you may heard about the formal charge related to this topic, and formal charge is related to the charges of a compound, and which you have to study, or you have studied in Lewis dot structure. And this way we have completed. For finding out bond pairs, just see how much or how many atoms attached to central metal, or how many atoms is bonded. There is 5 chlorine, that means bond pair will be 5 there. Then if the total number of Z is 5 and all the 5 contains bond pair, then lone pair will be 0. Okay, 5 0. 5 0 in the sense it will be 5 0 means what will be the shape? I already written the shape. Just see the shapes. It will be trigonal. Bone pair, lone pair 0, bone pair 5. It will be trigonal, bipyramidal, pyramidal. Okay. So this is how you can find out the shape. So just now I am trying to draw the structure, just like central atom will be in the center. Then for drawing the structure trigonal bipyramidal, make the planar, make a plane. Okay, this is planar structure and this is called trigonal planar. Okay, planar. Okay, then the bond in plane. Okay, phosphorus bonded with 3 uh, chlorine in the plane, and 2 chlorine above and below the plane. Okay, above and below the plane. This is the structure of trigonal bipyramidal. Okay, so now see the next structure. Next compound is VRF3. Follow the rules, find out the values of Z. Z is equal to half of. So this is central metal atom is bromine. Then the valence electron bromine for halogen is 7. Then monovalent, number of monovalent atom, that is 3 fluorine, then it will be 7 plus 3, that is 10 by 2, again it will be 5. Now for 5 you have to see the bone pairs as well as lone pairs. Okay, because 5 is, this is called Z, and Z contain summation of bone pair plus lone pair. Okay, so for finding out the values of bone pair, just see the how much atom is bonded. 3 atom is bonded with central atom, then the bone pair will be 3. Lone pair, then how we can find out the values of lone pair? 5 minus 3, because 5 is bone pair plus lone pair. Then 5 minus 3, it will be 2. It is the lone pair. Okay, then 3 2, the shape will be 3 2. I already have written the shape. This is T shape. Okay, so now how we can write, or how we can draw the shape T shape, that is central atom is bromine. Then you have to make a plane or trigonal planar shape. After that, above and below the plane, and this is geometry is trigonal bipyramidal, but shape will be T shape. Okay, so for T shape, looking like this is T, this one, and this bond. These 3 bonds all together, it is looks like T. Okay, so to just see the shape. Okay, so then fluorine, and fluorine. 3 fluorine all together, and this is makes T, and 2 positions which will occupy with lone pair. Okay, 2 lone pair. Okay, these 2 lone pair will be in these 2 position. Now little bit concept related to this, why bone pair a particularly in these 2 position, or why lone pair is in particularly in plane. Okay, this is called equatorial position, equatorial position. And this is called, this 2 position is called axial position. So 3 equatorial position, this one, and these 3 are equatorial. So just for minimize the repulsion, or for minimum repulsion, maximum stability of the compound. And here you can see these 2 lone pairs is apart, or these 2 bone pairs will far apart from 120-degree. If you make the lone pair in this position, axial position, then the one from one position it will be from 90-degree, apart from 90-degree, and another fluorine it will be again 90-degree. That means these, in this position it will feel, or compound will feel more repulsion, but in these 2 position this lone pair is apart from this 120 degree as well as from this